Hope you are keeping safe. So today, in this video, I am going to teach you electrophilic substitution reaction. On the electrophilic substitution reaction, there are different types of reaction. So first, let us study halogenation. Halogenation means addition of halogen. So let us take this haloarene, that is chlorobenzene. Reacts with Cl2 in presence of FeCl3. Now this FeCl3 is a Lewis acid, and it will help in the generation of electrophile from here, from Cl2, and that's how halogenation reaction will take place. Now we have seen the resonance structures of chlorobenzene, and from the resonance structure you'll see there is negatively charged carbon at 2, 4 and 6. So the electrophile will prefer to attack carbon 2, carbon 4 and carbon 6. So you'll get two products here. First, the electrophile will attack at carbon 2, and in the second compound the electrophile will attack carbon 4. Now if it attacks carbon 6, again it will become 1, 2. So the substitution of electrophile at carbon 2 or carbon 6 will give the same product. So we get two products. First one is 1, 2 dichlorobenzene, and the second product is 1, 4 dichlorobenzene. So this is halogenation reaction. Next, let us see nitration reaction. So in nitration reaction, let us take the substrate to be chlorobenzene, and the reagent used for nitration reaction is nitric acid, HNO3, in presence of concentrated sulfuric acid, that is H2SO4. So here the electrophile is NO2, that is nitro group. That's why this reaction is known as nitration reaction. So the nitro group will attack carbon 2 and carbon 4 to give two different products. So the product formed in nitration reaction are two nitrochlorobenzene and 4-nitrochlorobenzene. So this reaction is more or less like halogenation, just the electrophile changes. In case of halogenation, the electrophile is a halogen atom. In case of nitration, the electrophile is nitro group, that is NO2. Next, let us study sulfonation. So in sulfonation, we'll add sulfur group. Let us take the substrate to be chlorobenzene, and the reagent used here is sulfuric acid, H2SO4. So when we use sulfuric acid, the sulfur group, that is SO3H, will be added at carbon 2 and carbon 4. So you will get these two products. So The name of this compound is 1,2,2-chlorobenzene sulfonic acid, and this is 4-chlorobenzene sulfonic acid. Next, let us see Friedel-Crafts reaction. So there are two types of Friedel-Crafts reactions: Friedel-Crafts Alkylation and Friedel-Crafts Isolation. As you can understand from the name, in alkylation we'll add alkyl group like CS3, C2H5, etc. Whereas in acylation we'll add acyl group, that is RCO. Example, CS3CO. So let us try to understand this reaction with the help of example. So first we'll study Friedel-Crafts alkylation. Chlorobenzene will react with methyl chloride in presence of anhydrous aluminum chloride. This anhydrous aluminum chloride will act as Lewis acid, and it will help in the generation of electrophile from CH3Cl. So the electrophile here will be CH3. So CH3, that is methyl group, will attack carbon 2 and carbon 4, and that's how we'll get two different types of products. So these two products are formed. The name of this product, this is known as 1,2,2-chloro, and benzene ring with CH3 is known as toluene. So the name of this compound is 2-chlorotoluene, whereas this is 4-chlorotoluene. So this is your Friedel-Crafts alkylation. Next, let us see Friedel-Crafts acylation. So we'll take chlorobenzene, CH3COCl. This is known as acyl chloride in presence of anhydrous aluminum chloride. So the electrophile here is CH3CO. So we'll get two products. So these are the two products formed. The name of this product is 1,2,2-chloroacetophenone. This is 4-chloroacetophenone. Next, let us see the reduction reaction of haloarene. We'll take chlorobenzene, so chlorobenzene undergoes reduction in presence of nickel aluminum alloy in alkali medium to form benzene. So this is an example of reduction reaction. Next, let us study the name reaction of haloarene. So we'll study two different types of name reaction. First is Wurtz-Fittig reaction. So in Wurtz-Fittig reaction, a mixture of haloarene and haloalkane reacts with sodium metal in dry ether medium to form alkyl benzene. Let us try to answer with the help of an example. So we'll take chlorobenzene and methyl chloride and let it react with sodium metal in dry ether medium. So sodium will take the chlorine atoms and will go out as NaCl, sodium chloride. And the product form is benzene ring with CS3. That means the sodium metal will take both the chlorine atoms and will go out as NaCl, and this CS3 will combine with the benzene ring. And this is alkyl benzene. This compound is known as toluene, or we can say methyl benzene. Next, Fittig reaction. In Fittig reaction, haloarene reacts with sodium metal in dry ether medium to form biphenyl. So you can see the difference. In Wurtz-Fittig reaction, we take mixture of haloarene and haloalkane. But in Fittig reaction, we take two molecules of haloarene. And two molecules of haloarene will react with sodium metal in dry ether medium to form biphenyl. The name of this compound is biphenyl. And this reaction is very important because even in conversion of one compound to another compound, you get this. The question will be like convert chlorobenzene to biphenyl, or say convert chlorobenzene and methyl chloride to toluene. Next, reaction with lithium. So let us take a haloarene, that is chlorobenzene. If it reacts with lithium, it will form this compound, that is Cl replaced by Li. Okay, so thank you. That's all for today.